Okay, guys, this is another question from 2022 AMC 10A. Okay, this is number 13, and you probably heard me saying a lot, like the similar triangles are a big deal usually, as well as the Pythagorean, even though they are kind of simple for most people. But this was one of the question I'm gonna actually use that with the similar triangles. Okay, so anyway, so let's get started. It says ABC is a scalene triangle. So let's actually start with drawing that, something like this. Okay, I'm gonna name this ABC. So it says point P lies on BC, okay, such that AP bisect BAC, okay. So I'll draw a angle bisector. So it should be divide angle A into the equal pieces, and that's P. So the angle right here are equal to each other, okay? And the line through B, okay, line through B, perpendicular to AP. Okay, let me try to think about how that looks like. So it should go through B, and it has to be perpendicular to AB. So it looks like, so I do have, okay, maybe something like this. So again, the figure is not really accurate maybe, but it's okay. Based on what they are telling, so this guy is 90 degrees, okay? So the line through B, perpendicular AP, intersect the line through A, okay? There's another line goes through A, that is parallel to BC, okay? Then I will have a line that should be parallel to BC, but needs to go through point A, okay? And they are intersecting at one point. That point is called D. Okay, that's interesting. So the question is now, right? We had some information. BP is 2, PC is 3, right? And we want to find the AD. Okay, this is what we want. Okay, so a couple of things like before you maybe start doing anything. The first, you just really want to use every like single information that's given. Okay, and also you really want to pay attention what you are looking for. In this case, AD is what we want, and then what we know is just these two guys, and as well as the angle bisector. And if you don't remember the angle bisector, which is something we need to, I'm going to remind that a bit as a just reminder. So when you have a triangle, okay, let's say this is the angle bisector. So let's say this is A, this is B. AB is angle bisector. That's the right angle A into the equal pieces. So we have XY, let's say AB. So the ratio of this piece to that piece, which is X over A, is equal to ratio of this to that guy, which is Y over B. And this ratio is called angle bisector theorem, okay? So if you don't know about this one, this is actually a like relation that we need to remember, and then you can actually prove this relation using some similar triangles. But anyway, that's not the point right now. So that's called angle bisector. So based on that, in our problem, I can say, you know, the angle right here, the left side of this guy is AB, divided by the opposite is B, like 2, is equal to AC for this guy, like this angle. Just ignore this line for now, because that's the triangle. That is actually, this angle is divided by this bisector. So AB divided by 2, AC divided by 3 is equal. So then if I call AB as like 2x, then AC should be 3x. But at the same time, you know, this is bisector, and at the same time, that segment is actually perpendicular to this line. So, you know, that will give me a isosceles triangle, because the bisector is at the same time the altitude. So then AB, if I call this, let's say T, AT and AB should be same. So that means this is also 2x. And then since we know AB was 2x, AC was 3x, so that's 2x. So that means TC should be 1x. And that is something. At this point, then you can try to see another two triangles to see they are similar, but at the same time, you know, we have x and 2x, we probably want to use that. And then we know BC, we know these two pieces, and then that's what we wanted. So if you see that this triangle right here and this triangle right here is actually similar. So the reason it's similar, you know, the angle right here is the same as this angle because we were told these two guys are parallel. Okay, so the angle right here is same as this guy, which is alternate interior. And with the same reasoning, so I do have the angle right here, and the angle right here is also same. So I have already two pairs of angles in this triangle and this triangle are equal. So then this guy and this guy also equal because they are vertical angles. So they are similar by angle-angle similarity. Okay, so now we can see the ratio. Ratio, like for this red angle is opposite to 2x. This red angle is opposite to 1x. The ratio is 2 to 1. Then this BC was 5. That means AD has to be 10. And that is your answer. Okay, so I hope that makes sense. But again, this is just the brief reminder for the similar triangles, which is we really need to get better at. Okay, so that's the answer for number 13.